Hi guys, in today's video we're going to be learning to use something called Pythagoras Theorem to calculate an unknown side of a right-angled triangle. Now, before doing any of this, you need to have a wee bit of background knowledge. So the main background knowledge today is going to be around algebra, because we're going to be using some letters to stand in for numbers. And also you need to be able to know how to square and unsquare numbers. So a square number is a number times itself. So for instance, 3 squared is 3 times 3, which is 9. And the opposite of squaring something is finding its square root. So the square root of 9 is 3. If you know all this sort of stuff, if you're perfectly comfortable with algebra and square numbers, then you easily know everything that you need to know in order to solve problems involving Pythagoras Theorem. So let's get started. We have here a right-angle triangle. It has to be a right-angle triangle for Pythagoras Theorem to work. So this is a 90-degree turn here. That means that we have a completely vertical surface, a completely horizontal surface, and then a diagonal surface that is longer than the other two. Now, we're going to give each of these edges names. So this shorter edge here, we're going to call A, and this horizontal edge here, we're going to call B. Now, really, it doesn't matter which one you call A and which one you call B. That doesn't matter. However, the long diagonal one has to be called C in this case. So the hypotenuse, the longer diagonal edge, is always C in Pythagoras Theorem. Now, Pythagoras Theorem itself is basically just a rule that helps us work out any one of these sides as long as we have the other two. And it states that A squared plus B squared equals C squared. So if I take A here and times it by itself, and B here and times it by itself, it will be equal to C when it's been times by itself, which means that we can always work out one side if we have the other two. Let's look at an example of this, and hopefully it'll become a bit clearer. So here's a right-angle triangle. We've got A, we've got B, and the longer diagonal edge is C. Now, at the moment, we'll say that we don't know what C is. However, we can work out, just by counting the boxes, what A and B is. So in this case, A is 7 and B is 6. So, Pythagoras Theorem then. A squared plus B squared equals C squared. We don't know what C squared is, but we can work it out. So, let's plug in the numbers to replace the letters. So A squared, that is 7 squared. B squared, well, that's going to be 6 squared. So 7 squared plus 6 squared equals C squared. Not C, it doesn't tell us what C is straight away, but it tells us C squared. Okay, well, let's solve this just a second. 7 squared, that's 7 times 7, that's 49. 6 squared, well, that's 6 times 6, that's 36, and that equals C squared. Now, at the side here, I'm going to do a wee calculation to work that out. 49 plus 36, because that's what this tells us to do. We add A squared and B squared together. So 9 plus 6 is 15. 4 plus 1 plus 3 is 8. So that means that C squared is 85. However, I'm looking at this and I'm thinking there is no way that that is 85. So if this is 7 and that's 6, this is not 85. And that's because what we've worked out here is C squared. We need to unsquare it in order to work out what C is. So it'll really help if you have a calculator for this. Really, you need to have a calculator for most of these. But what we do is we find the square root button. We're unsquaring C squared to then find the square root of 85. Now, when we plug that into our calculator, we get the answer of approximately 9.2. So C, in this case, would be 9.2. And that would make sense. If this is 7 and this is 6, well then, yeah, that would be about 9.2. So that works. Okay, so here's another example. So again, we've got A, B, and then C has to be the hypotenuse, the longer diagonal edge. And in this case, so we have A squared plus B squared equals C squared, just like before. And in this case, A is 6, B is 3, and that will tell us whatever C squared is. So 6 squared, first of all, well, that's 36. 3 squared, well, that's 9. So 36 plus 9 tells us what C squared is. Now that's one that we can easily do ourselves. It's 45. So C squared is 45. So to work out C then, we're going to have to unsquare 45. So we find the square root of 45. And when we plug that into our calculator, we get 6.7. So C in this case is going to be 6.7. So one final example then, and this one's a little bit trickier because this time we know what C is, we know the hypotenuse, and we know what B is. But our unknown this time is A. So let's stick to the formula so far. A squared plus B squared equals C squared. Just like before. And again, we're going to plug in our knowns. We're going to plug in the things that we know. So A, we don't know what that is. So we're going to leave it as A squared. But we can do 6 squared. And we can do 7.2 squared. So when we do that, what we end up with is 36 and 52. So, okay, we have A squared plus 36 equals 52. Well, if you know anything about algebra, we should be able to rearrange this to work out what A squared is. So, we have our A squared, and when we add 36 to it, it equals 52. Well, what we need is we need to get A squared on its own. How do we do that? We take away 36 from this side, and that gives us A squared on its own. But that means we need to take away 36 from this side. That's going to be 52 take away 36. The answer to which we can work out with a quick calculation here. What we get is 16. So A squared equals 16. But that's A squared. We want just A. So to work out A on its own, we're going to have to do the square root of 16. So A equals the square root of 16. And if you know your squared numbers pretty well, you should be able to know automatically that the square root of 16 is 4. And sure enough, when I weak this out of the way and we can see the boxes, we see, yep, right enough, that's 6. And this one here, sure enough, is 4. So there you go. A squared plus B squared equals C squared. Makes sense. All you need to do is work out what each one of those squared numbers is, and then rearrange the formula if you need to in order to work out any of the other sides. Cheers, guys.